Hi viewers, welcome back to our channel Raveendra for Students. In this video we are going to see how to find the capacitance of a parallel plate capacitor. So let us draw the diagram in order to find the capacitance of parallel plate capacitor. So since from the name itself there should be two parallel plates, so let us assume that there is one parallel plate like this and another parallel plate like this. So both are having an equal area of A. And let us assume these two parallel plates are, the first one is at the origin and the second one is at a distance of D in vertical Y direction. You can take in some other direction also, no problem. Then to have the capacitance between these two plates, the medium between these two plates should have a dielectric constant of epsilon or the permittivity epsilon should be uniform, and that is the first requirement. And the second one is to have the capacitance between these two plates, if the first one is having 4 positive charges like this, then another plate should have 4 negative charges. To have the capacitance, the two conductors should have equal and opposite amount of charges. So due to this arrangement, what will happen is from this positive to negative an electric field will be developed. So let us consider this electric field component as some E rho. Then due to this E rho, how much capacitance will be formed between these two plates we are going to calculate by using the general formula for any capacitor is C equals to Q by V. Now let us find out Q. So to find out Q, we are using Gauss law, which is given by double closed integral over S d bar dot ds bar. Then here you can write it as double closed integral over S. In place of d bar, we are having epsilon E bar. Then instead of seeing the total E bar, so let us see only first the E rho component between one positive charge and one negative charge dot ds bar. Then here epsilon, E rho, they are constants, then we can take them outside of the integral. Then double closed integral over S, so what is remaining is ds bar. So this double closed integral over S ds bar is nothing but the surface area of the parallel plates, and already we have assumed the area as A, therefore it will be epsilon into E rho into A. So left hand side we are having Q. So from this we can write E rho equals to Q by epsilon A, or in general you can write E bar, that is the total electric field, is given by Q by epsilon A into the unit vector along the row, that is rho bar. So this is E bar, the total E bar in this parallel plates arrangement. Now, so in the process of finding Q, we have evaluated E bar. Now let us see how to find out another parameter V also. So we know that V is expressed in terms of E bar as minus integral over L E bar dot dl bar. Why? Because here already we know the E bar, this is E bar. Now here going back to the diagram, so why we have considered negative sign here? Because it is due to the external work done in opposite direction of the original force existing due to the charge distribution. And here coming to integral over L, so here, so let us consider this as conductor 1 and this as conductor 2. We are having the electric field from conductor 1 to conductor 2, that is plate 1 to plate 2, separated by a distance of D. Then the integral will become D to 0. So this is minus D to 0, and E bar already we are having as Q by epsilon A rho bar, and dot dl bar. So what is dl bar along rho bar? So dl bar along rho bar, we know it is d rho A rho bar. So it is d rho into arrow bar. So we know arrow bar dot arrow bar is 1. Therefore it is minus q by epsilon a. They are constants writing outside of the integral, and integral d to 0. So what we are having is d rho. So we need to do the integration only for d rho. So which is given by minus q by epsilon a. So for d rho it is rho. Then the limits d to 0. Then applying the limits, so it is minus q by epsilon a into 0 minus d. So taking minus outside, then you will get it is q by epsilon a. So left hand side what we are having? V. So what we want actually is C, which is given by q by V. So therefore q by V here we will get, so it is here we are having d also in the numerator. Minus minus gets cancelled. So C equals to q by V is given by epsilon a by d. So this is the capacitance of a parallel plate arrangement, so which is measured in farads. It is measured in farads. So like this we can find the capacitance in terms of field components, that is Q using Gauss law and V using the relation between E bar and V very easily in field theory than circuit theory.